attacked by mechanic erosion, the high mountains will start breaking down, producing large amounts of detritus. The blocks will fall and, driven by gravity, pile up on the flanks of the mountains, ready to be taken over by rivers and transported to their final destination, the sedimentary basins. The overall term we use to describe these movements of rocks is mass wasting. Understanding of mass wasting process is of crucial importance not only for sedimentological purposes, but also for more applied goals such as landslide control. The process of falling and piling up can be best understood looking at what happens to sand grains which continuously fall on a flat surface. Falling grains will start forming a small cone which will grow in size. Interestingly, it will grow, but the angle of the cone will remain constant throughout the process. This angle is called angle of repose, and it is a very important property of the sediment in question. The magnitude of the angle of repose depends on the sediments. Fine-grained, water-saturated sediments, for instance, have an angle of repose close to 0. Dry sands have angles of repose in the order of 20 and 30 degrees. Higher angles are very rare. This link between angle of repose and characteristics of the sediment is of great importance for subsurface studies because it can be used to predict sediment grain size. In the slide, you see a vertical section across a prograde delta system. You can see that the steeper layers are made up of coarse sand, while shale forms the flat-lying layers. Let us now look at how the cone grows while preserving its angle of repose. This will give us some insight on how phenomena like landslides and avalanches occur. In the simplest way, grains would roll down the slope and create regularly a new layer with the thickness of the grains. In reality, however, things are much less predictable and avalanches often occur with variable magnitudes. You can look at the YouTube film indicator to have a better idea. If we plot the frequency of events of a specific magnitude on a logarithmic scale, we discover that the points fall all along a line. It seems that the system is able to regulate itself. A major conclusion is that mass waste are not deterministic processes. Predicting the magnitude is very difficult. A key issue of mass wasting is obviously that of the stability of the slopes of the cone. The first order physics is simple. The blocks on the slope are stable as long as the component of gravity along the slope is smaller than the friction at the base. When this equilibrium is modified, the block will start moving. Let us see some factors which can bring the setting out of equilibrium and thereby create a slide. Instability can be generated by increasing the weight of the block or on the block, for instance by precipitation infiltrating the rock, or by people building a house. Alternatively, a landslide can be triggered by a reduction of the friction coefficient at the base of the rock. This is typically achieved during large precipitations when water infiltrates into the detachment domain. In a quite sudden manner, gliding or collapsing, the sediments will have reached the valley floor. Here, the river will remove them, causing further mass wasting and gliding over rocks. The sediments will start a new journey, this time with a very different vehicle, water.